Hi everyone, so this is a continuation of the macromolecules lessons, and I'm actually going to really focus here on distinguishing between the structures of different classes of macromolecules. Now, these aren't full notes, but if you do choose to take notes on this, I would add it to your macromolecule notes. Otherwise, make sure you understand how to do this. There should be worksheets and some other stuff if you're assigned this section of notes. There should be worksheets or something to help you practice your skills on identifying different macromolecules. Right, so let's look over the different macromolecule structures. Carbohydrates are CHO, carbon, hydrogen, and oxygen. And they're always rings with lots of O on the corners of the rings. This is opposed to lipids. Lipids may have rings, but the O's will not be in the corner. So in this case, this has a ring, but look, there's an O on the corner, so now I know it's a carbohydrate. Okay? Lipid rings are going to be glued side by side to each other, or you're going to see hydrocarbon tails, meaning you're going to see a large stretch here for lipid, if there's a lipid of just C, 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 with lots of H's all over the C's and not a lot else. There may be a side of it that has phosphate or a weird carbon chain on it, but this huge stretch of C's with just H's on them, that's the tip for it to be a lipid because it's got that fatty acid. Another thing that may happen is that C chain may have a double bond in the middle of it and slightly less C's. Sorry, gotta erase stuff so you can kind of see that. But it's still just C's and H's for a long stretch or long sections of the molecule. Proteins, you're going to see this NCC pattern. You'll see it later on, along with that repeating stuff in the middle. So the middle C will have like kind of a weird stuff attached to it, but the other N and C will be pretty consistent looking. And finally, nucleic acids will have a sugar ring. It'll just have like 3 random sections: a sugar ring, a phosphate something attached here, and then some kind of ring type structure with the N inside of it will be seen in your nucleic acids. One other thing I want to mention, sometimes people, when drawing out the molecules, because they're so long and so annoying to draw out, we cheat a little bit, and instead, because we know all carbons have to have 4 bonds, sometimes instead what we do is, and we go, any carbon that's only attached to any corner basically of 2 lines that doesn't have anything drawn on it, we assume is a carbon. And that carbon, because it's a carbon, has to have 4 bonds. Anything that's not attached to that carbon, we assume is an imaginary H. So if I wanted to draw this molecule out, I could also draw it like this, which is like fun. I don't even need C there. This is like fundamentally the laziest way you can draw the same molecule out and still have the same information with just an OH here, because it's not hydrogen. I have to put the O there. Because it's not hydrogen, I have to put the O here. I have to put the O here, the O here, and then that's a carbon, and then it's got an O on it. Fundamentally, this is this, but just drawn out in the laziest manner possible. Okay? So just a heads up. Sometimes they'll be even lazier than that. Sometimes they won't even draw all that detail out, and they'll just like literally just do that. And you should know, oh, that's a carbohydrate, because I see a ring with the O on the corner and nothing else. Okay, so here's a classic example of how we be lazy when we write out molecules if we want to. I'm not really going to go over how to do that. I used to do that. It's not a huge deal. Just be aware that this is still a molecule, just written in shorthand, in a cheater's short, lazy way. Okay, so let's go over examples. So this molecule, what is this? It's a carb, lipid, protein, nucleic acid. You see this huge stress of C's and H's. So that's how I know it's a lipid. Okay? Now, is this lipid saturated or unsaturated? Now, if you think of the definition, remember, along the CH stretch, if there's double bonds, any double bond, it becomes unsaturated. All right, looking at this, I see N, a C, a C. I see another NCC. I see another NCC. The middle C gets to kind of be dealer's choice and should be consistent. It's either all kind of weird on the bottom or all kind of weird on the top. And the other side should be consistent with a single H. And you should see kind of consistently on the second C in the NCC a double bond. Double bond, double bond, double bond. All right, that's how I know it's a protein. Also with the protein, it's one of the few macromolecules with an S in it. So again, you see this S here? See this S here? And that's my hint that it's a protein because I see an O, I see an H, I see C's, I see N, and I have that S, that very rare S. All right, this one I went over earlier, but I know it's a carbohydrate because I have lots of that hexagonal or pentagon rings with an O on a corner. Lots of O's on each ring. That's how I know it's a carbohydrate. And again, my rings are not all squished together in that weird way like a steroid. This one, I see my O ring, but I also see N rings, and I see phosphorus. Hey, I have a phosphate, a sugar, and a ring with N, nucleic acid. Over here, what is it? I have rings, but there's no O's on my corners of the rings. They're all squished together in a weird way. That's how I know it's a lipid. And, by the way, not just any lipid, a steroid lipid. All right, so this one's probably the trickiest, so take a moment, see if you can figure it out. All right, so did you figure it out? Now remember, the corners that you do not get labeled, those are carbons. So this is an N, followed by a C, and then a C. N, C, C, N, C, C, N, C, C, with the last C in the NCC being a double O, which that always is the case, and the middle C being the one that's got weird stuff on it. And that is definitely the case here. So a lot of N, weird C, second C with a double bonded O. And that's how I know it's a protein. This is the toughest one, and I wouldn't anticipate this being on any huge assignments, but if you already spotted that it was a protein, that's a really good sign that you got this down. All right, so that's a run through on identifying macromolecules. Hopefully that gives you a little bit better grasp on how to identify macromolecules so that any other assignments related to identifying macromolecules goes more smoothly. Bye.